We're going to cover properties of trapezoids and kites, and you need that note sheet. Again, the one with all the rectangles all over it. 6.5. It looks like this. We wrote all that last time. We're going to add to it now. We're going to add something on to this one, something to that one, and then lastly, something down. We'll not get there. We got kites and trapezoids. We're going to put kites to the left and trapezoids to the right. We're going to talk about what those are. When I bring up properties, you just make sure you put them right in those note sheets right there, those boxes that I've given to you on your note sheet. Okay. We're lastly going to do this one, isosceles trapezoids, special trapezoids. I want you to notice is based on this picture here on this note sheet, is a kite going to be a parallelogram?
No.
Is a trapezoid going to be a parallelogram?
No.
What is it going to be?
Quadrilateral.
It's going to be a quadrilateral. So it'll have 4 sides, but the properties of the parallelograms will not apply to kites and trapezoids. There might be some similarities and things with some of the, but all of the parallelogram properties will not apply to kites and trapezoids. Will the properties of trapezoids flow down to this isosceles trapezoids?
Yeah.
Yes. Okay. All right, so here's a trapezoid. This is a picture of a trapezoid. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. Not 2, but only 1. Okay? So you can put that inside your note up there in that little box for it. If you want to abbreviate it in some way, you can draw a picture of it next to it, or inside if you need to, because we're going to label some parts of that trapezoid. The parallel sides are going to be called the bases. Over here, these are the parallel ones, so those are called the bases. I wouldn't necessarily write those as words. I might actually write the word bases right next to the picture. I think that would probably be something that would conserve on space. Your non-parallel sides are going to be called legs. We have seen this when we were doing triangles. Triangles. We had especially when we did isosceles triangles.
So don't write this inside here in the box you said?
I would draw the picture and actually put them in. So this is what I would suggest you do. I suggest that you draw a trapezoid and put the word base on it. Okay? Or put the one word base and put arrows to it. I don't know, that's just an idea also. Okay?
Just do it to the parallel 4 sides.
The ones that are parallel are the ones that are called the bases. So I would only write the word base on the ones here that are parallel. So the legs are the ones on the sides, the ones that are not parallel. Your base angles are going to be the ones, your pairs, they're going to be the ones, these are going to be base angles. They're also going to have base angles at the top too, in this case the top. But you have pairs of them. The 2 at the bottom are going to be paired up, not necessarily congruent. And the ones at the top are going to be paired up, not necessarily congruent. Sometimes they will be. Are there any questions about all this? Right now this is vocabulary, but I want to make sure you understand this so that we can go on, because you need to know your vocabulary to be able to do it, do everything you need to. All right, so if you haven't written it so far, you should have written that a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. Somehow you wrote that. And I drew a picture that looks like this. You didn't have to. You could have drawn the picture that I had on the previous page. We labeled it with the words possibly base and legs and base angles. Okay. Let's talk about an isosceles trapezoid. This is going to go down in the box below. An isosceles trapezoid, if the legs of a trapezoid are congruent, then the trapezoid is isosceles. So you have to have these legs being congruent for them to be an isosceles trapezoid, similar to an isosceles triangle. So you might just write something about legs are congruent. Trapezoid with legs congruent. You don't have to write every single thing if you don't want it that. Whatever makes it easier for you and that fills in that box. You also need to know that each of those base angles are congruent to each other. Not all 4 of them. You can also go the converse of that. If the base angles are congruent, then it is a trapezoid. So I'm going to draw those. That means that these angles here are congruent to each other. And the top 2 are going to be congruent to each other. You're welcome to draw a picture. I like seeing pictures when I do my work. I think that it helps me to understand things a little better. We got this backwards thing. Trapezoid is isosceles if and only if one less thing. The diagonals are congruent. Where have we seen diagonals congruent before?
Parallelogram.
Some kind of parallelogram. Which kind of?
Rectangle?
That's correct. With rectangles. If it's isosceles, the diagonals are congruent. That is the same as a rectangle. Remember I said that they might share some of the properties of parallelograms, but not everything. This is one of the few that the diagonals are congruent, like a rectangle had the diagonals congruent. So you could draw yourself some diagonals. Do they bisect each other? So if I do the top, no, they don't.
No, they don't.
No, they don't. So your diagonals are congruent. I'm trying to see how you mark that. You might just label the letters. You might do A, B, C, D, and you might say that AC is congruent. Let me make this a little bigger so I can write. AC is congruent to DB. Yeah. My trapezoid my example for you was isosceles at the beginning. That's probably why.
Well, and I was trying to save space because there's not enough room to draw it on
Yeah.
the side right here,
Right.
so I was drawing it in between
Yeah.
the two.
Makes sense. All right, so we just drew, and I put an isosceles triangle up, excuse me, isosceles trapezoid up here. The legs are congruent, and the pair of bases are congruent, and their diagonals are congruent. Lots of things congruent on a trapezoid, isosceles trapezoid. All right, we're going to do some examples. I wanted to keep us with the trapezoids before we moved on to kites. 28, 30, 32, and 34. Yes, bless you. It's a couple pages in.
Oh, yeah, I see it.
Couple pages in, because the first page has stuff to do with kites. We're going to skip that for a quick minute. All right, find the measures of the angle indicated. Now, this is a trapezoid. And we know with the trapezoid that these are parallel. So everything you know about parallel lines and transversals applies to trapezoids too. So we got a lot of things that are applying from chapters before. What do we know about angles that are same side interior angles? They're supplementary. So if that one plus that one equals 180, what can I do to find the question mark?
180 minus 85.
Yes. Yes, ma'am.
The reason I'm asking is because my dad tried to do it this way, but could
Yes.
you take this and do like 85 plus x equals 180?
Yes, that would be the same thing. 180 plus x equals...
Which is what you're going to have to do for 30.
No, my
31.
bad. You have to do 85 plus x equals 180. Yes, it will be the same thing because we'll be subtracting the 180 to the other side. Right. I got x equaling how much?
95.
Yes. Next one down. Try not to do 29 right now. Let's just concentrate on this. Now, this, Amy, this direction, we're going to have to set up
You
an
have to
equation.
do it
Okay?
because it's-
So we're going to have to do it the way you have learned it. We're going to have to do it the 120 plus 10x minus 20 equals 180.
Isn't it?
I'm going to move the 100 over.
Oh.
So I'll have 10x equaling 80.
Right.
Is that what you got so far? Good.
Are we gonna, okay, good. We are going over 30.
Yes, and then I am going to divide by 10 on both sides. So x will equal 8. Okay. Are we at the same spot? Okay, we're at the same spot? Okay. Let's go to 32. This time we have what kind of a trapezoid right there?
Isosceles.
We have isosceles, and they asked us to find the measure of the indicated angle. We only have one of them. Are opposite angles in a trapezoid congruent?
No.
No. But what do we know about this angle?
Then it's congruent to 50, so that means that those two are same side interior, so that way we can set them supplementary.
Oh, so these two might be, oh, they are. Okay, so this is parallel, correct?
Yes.
And so
Because it tells us that it's a trapezoid.
it tells us it's a trapezoid. So then we know that these two, oh my goodness, are same side interior right here. So we can,
Set them supplementary.
so we set them supplementary. So we can say that 50 plus x equals 180. Or if you don't want to do it that way, Amy, you could take 180 minus 50,
That's what I did.
which will be the
It's a lot
same.
easier to just do it that way.
Yes,
It's less writing.
right. I got 100 and what?
30.
Yes.
That's what I got.
You can put the degrees if you want. All right, this tells us, find the length
Okay, sorry.
indicated, oh, actually, length of the diagonal indicated for each trapezoid.
Sorry. Never mind, you already
To
answered
me, it
that.
almost looks like a square from my direction. No, now I want to get
It's
like
not-
straight
it's
on.
an exact square.
It's not, it's
exactly.
not.
It's really close.
What do we know about the diagonals of a trapezoid? You want to look on your notes?
Congruent.
They are congruent. So they
It's
gave
only
us
for isosceles, though.
only for, is this isosceles?
Yes.
How do you know it's isosceles?
The
As
two
you can tell on the side.
Two little sides there, correct. So if GE is 13, what is HF?
13.
Yes, done. We have something still to talk about trapezoids before we go on. I don't have a special place for notes on this, but you have the back side of that sheet. You might be getting the trapezoid section filled up.
It is.
So you might want to move to the back. It's just a suggestion. You can put a little note with back. We had mid-segments of triangles. Now we're going to have mid-segments of trapezoids. They're very, very similar. I would suggest you draw a trapezoid. Notice that mine is not isosceles. We're going to talk about something called a mid-segment. I'm going to just have us review really quick. When we had a triangle, I have a tendency to draw equilateral triangles. There we go. A mid-segment for a triangle is when we connected the midpoint of the sides. What was the properties of that mid-segment? There were two of them.
It bisected the sides.
It bisected the sides. Yes. What else?
Wasn't it parallel to the base?
It was parallel to the base. What else?
It was half the base. Half the base.
Half the length of the base. Very good. So if this one was 16, that one was 8. Okay? Let's clear everything and now talk about mid-segments of a trapezoid. The reason I brought up that about the triangles is because it's very similar. All right, the mid-segment of a trapezoid connects the midpoints of the legs. That is exactly how we did it with triangles. So that means that these distances here are congruent, okay, because we connected the midpoints. There are two properties, just like there were two properties for triangles, there are two properties for the mid-segments of trapezoids. You wrote these down in your postulate book already. The first one, it is parallel. This is a slight difference because the word bases is now plural, not singular like we had with a triangle. It is parallel to all of the bases. We had parallel to the base with triangles. We also had something about the length, and that's where we're going next. It has to do with half, but we have two bases now. And so it just so happens that it's half the sum of the two bases. And I'll talk about how to do that in a moment with some numbers. Half the sum. You probably got the word half already. Half is like divided by 2 or multiplying by a half. But what's the word sum mean?
Addition.
So we're going to add the two bases. Add the two bases and then divide by 2 to get the length of the mid-segment right there. We cut each of the legs into 2 equal parts and we connected their midpoints. We made a third parallel line. It was parallel to the bases. And its length was half the sum of the two. I would suggest that you write something about that on there, if you haven't done so already. We're now going to move over to kites. Oh, and I did this on that one, but it's totally, you guys did it on the back, okay? Parallel to the bases, and the length is half the sum of the bases. Somewhere you put that on there. You might put a little note on there that there's something on the back, so that you'll have something to refer to, okay? All right. Let's do some examples of that stuff with the midsegments. Number 36, 38, 40, and 42. This is a longer of the lessons. The last lesson is shorter.
Good. Oh my goodness.
This has a really long, that's where we're going to do quite a bit of examples together.
Whoa.
Why
Okay?
do you think I don't look at it until I go home and do
Yeah,
my homework?
don't get freaked out. All right, so number 36. Tell me the instructions for 36 because I cut mine off.
Solve for x each figure.
All right, solve for x. We have all these letters and stuff here in these numbers. We were told that this length is half the sum of the other. That means that 5x minus 12 is equal to half the sum. What is the sum of 20 and 46?
66.
66. So it's half of 66. Most of you don't like fractions, so if you want to write 66 over 2, that usually makes is a little bit makes you feel a little better. You could put half of it, but it's the same. So, and I got the 66 by adding the 20 plus the 46 together to get the 66.
Can we just put 66 divided by 2 with the actual division sign, or do we have to put it
You
on-
could put the actual division side. That'd be fine too. Yes. Yeah.
I just put the whole thing in the calculator. 1/2 open parentheses 20 plus 46.
Yes.
All
And you
at
got.
one
Did you
time.
get? What'd you get?
33.
That's what I got also. For the sake of time,
What?
the algebra
Yeah, it's
from
not.
here is not difficult. We're just gonna go to the next example. Okay, you can finish.
It's 9.
Wait.
He got 9. So if
So
you
we
want to,
do that.
I'm gonna leave the 5x minus 12
Yeah,
equals
I got the
33
same
to
thing
you to
back.
do at home. Okay.
What was she talking about the parentheses? I'm sorry,
She
that
did
confused
this in her calculator. She did open parentheses. No, she did a
1/2.
1/2 open
me.
parentheses.
Oh, she did like the
20
I did the whole
less
thing. I did that
46.
all all in one step.
Okay,
Just get it
you
over
just like
Got it
put
over
the- Okay.
Okay.
Got it over with. Just did it all at
Uh-huh.
once.
Yeah. Okay.
So let's do 38. I'm gonna leave you with the 5x minus 12 to do by yourself. Okay, Amy.
Okay.
All right, so let's go to 38 just to conserve on time. The algebra part's not something you guys usually have troubles with. How do I find the length of UT? Half of the sum, I'm going to put a half. The sum is 27 plus 17. One fell swoop, some of you can put that in your calculator as is. If you wanted to do it at the end, if you wanted to do the divide by 2 at the end, you can also do that. One fell swoop, 27 plus 17. You can put it in parentheses if you want.
So before you get your answer, how do you put the 1/2 in?
1 divide
Just-
2. 1.
So you can't
Divide
write it as a
2.
fraction, like an actual fraction. You
That
can't.
is an actual fraction actually. In parentheses.
Oh
That is
yeah,
that.
because
Yeah.
Okay.
Okay. And then 27 plus 17.
22.
22. Did anybody else get 22?
Yeah.
I
Okay.
did.
22. All right. Let's go to the next one. Number 40. 40 is solve for x. We're gonna go. It says our property says that the midsegment is, that's 3x minus 12, is half the sum. And what's the sum of 6 and 12?
18.
18. What's half of 18? 9. So it equals 9. I'm going to just write this out so you can get half. Know where I got the 9? For the sake of just time, we're going to let you do the algebra at home.
And then you just put. Okay.
Got it? All right, let's do the last one on this page. It's got some decimals this time, and it says that it's a trapezoid. But this time we don't have the midsegment. We have that one as our x. How do I do that? It says that the midsegment is half the sum of those, right? So 6.8 is half the sum of what and what? What about that half? Do you guys like the half?
No.
How did we get rid of the half before?
Can't you just multiply it by its reciprocal?
Yes, which is 2. And that's yes.
Oh, okay. So you just added an extra step.
I did.
Okay.
Okay.
So it's okay just doing it my way then, right?
Yes, it is. What is 6.8 times 2? Someone help me.
13.6.
Yeah.
13.6? Okay. 13.6 equals 6.8 plus x. I'm going to let you finish that one. There's a point.
Oh,
Because this canceled, right? That canceled. Okay. I'm going to let you finish. Are you allowed to give me decimals on this answer?
Yes.
Yes, because there are decimals in the original, right? Just for sake of time, you guys are doing algebra quite quickly, but we're going to spare the time because we're getting low on it. All right. Because we need to talk
Very
about
low.
kites eventually.
And a whole nother lesson, right?
Yeah, so I'm going to skip this one too. Skip that one there, 44. We're going to go to kites. All right, here we go. All right. Here is the picture of a kite, and yes, it does look like the kind that fly. We had some talk about that last time, a couple times ago about flying, the kites that fly. It does look like it. This is the definition for geometry, in geometry about a kite. It's a quadrilateral. It has 2 pair of consecutive congruent sides, but the opposite sides are not congruent. It has 2 pairs of consecutive congruent sides, but then all 4 of them, or opposite ones, are not.
Wait, so do we need to draw that picture?
I would, yes. And you have lots of room underneath your kite saying there. The box there, you have room for a kite. Consecutive sides, but not opposite sides. When I say consecutive, what am I meaning? Yes, correct. The ones right next to each other. 2 pairs of, so we have, on the one I've drawn here, I've got congruent there, and here with here. Okay? One's right next to each other. There are some neat properties that go with this. Not just that it flies well.
Mm-hmm.
The diagonals are perpendicular. That's one of the properties. Have we seen anything about diagonals being perpendicular? Very good, rhombuses. And I think, I didn't mean this, I maybe other things, but that was kind of actually quite interesting. If you notice, your kites are above rhombuses. And they have that. And your trapezoids had similarity with rectangles, and trapezoids are above rectangles. Not everything, just a couple things, okay? Diagonals are perpendicular. Exactly 1 pair of opposite angles are congruent. Not both. I want you to look at the picture up there that I have after you've written that down. We need to decide which of them are congruent. Which of the angles are congruent? We're going to base it on appearance this time. Which ones look like they might be congruent?
The 2 that are closest to this, the 2 that are, for us, up and down. On that picture.
So the top and bottom, not the left and rights.
Yes.
Yes. I've been trying to figure out if, I think it's always going to be the ones with the shorter diagonal. Not the long diagonal. I think those are always going to be the ones that are congruent. But I can't imagine, because this is always, one's always going to be like acute and obtuse, possibly acute, or just one smaller and bigger. So, here we go. Here's our marks. Here's our diagonals are perpendicular. I don't have anything about the opposite angles being congruent on a drawing, but you can draw those if you'd like. That kind of makes it nice. Markings in the drawings, diagonals are perpendicular. This is something you guys might need to remember. We know that if this is a right triangle, what formula can you use on right triangles?
Pythagorean?
There we go. Pythagorean theorem. You helped each other out. Good job. Prompted. Yes, good job.
I just know what it is. I don't remember the name.
You guys got it together. Good job.
Yeah.
Pythagorean theorem. All right. So another, what other diagram could you use the Pythagorean theorem on this sheet? Anything with what has 90-degree angles in some way?
Square.
Squares. rectangles, and we also had some other things we had that had at least bisect the diagonals are perpendicular, which were for rhombuses too. Okay, all right, all right. Up here we have kites. I have a picture of a kite there for you. You guys already drew one.
So basically, we can use the Pythagorean theorem in some way for everything except a trapezoid.
Sometimes, if
you
your
can use a trapezoid.
if your trapezoid had a right angle is
Like,
one of them.
That one
Like
up there at the top is close.
yeah, I
It's
suppose
close.
it's
a little
similar. Yeah,
obtuse, but it's close.
yeah. Our kites, we have a quadrilateral with two consecutive pair of congruent sides. I didn't have enough room for in my box, which you probably might not have either. And so here are the little properties that we have. We have diagonals that are perpendicular to each other, and one pair of opposite angles are congruent. There was something else.
No, that was it.
That was it? Okay, good. Good. All right. We've filled up this with tons of stuff. We even filled the back with this. Here is the very first page of your homework. We're going to do some of the stuff here. Use the given diagram to answer the following. Here's the diagram that you have at the top of your page. I put it on the side of mine just so it all fits. Okay, you have this. So number 5.
Can we list all the names for number 5.
We're going to move to number 5. I'll let you do that one. Number 5. We're going to jump to 5. I say that ED is a length of 4. And I say that CE is a length of 3. I want us to find CD.
7.
I heard 7. Do we add them together?
No, it's the Pythagorean theorem.
It is, because this is a right triangle.
Oh, I put that in 4, not.
So this is a right triangle right here. So what's A, what's B, and what's C?
C is what we're finding, because that's the
Hypotenuse. Good job. So we have 4 squared plus 3 squared equals C squared. This is exactly why we're doing this together, because you might not have thought of the Pythagorean theorem. Adding them together would be the most logical if you had done. I'm giving you work on the side there.
Do we solve this now, or?
Wait, do we put it in the box?
Yes, I was intending for you to have your work in the box there, but you can do it on some.
25.
I have yes because this is 16. This is 9. And
But then
so
we can take the square root of 25.
yes, so I have 16 plus 9. I'm going to put it in the box since I was supposed to in the first place. Equals, actually that's 25. Square root of both sides. What is the square root of 25? 5. I'm going to just, a little advertisement for second semester. You have a triangle
No.
Go ahead.
3,
just do it.
4, and 5. 3, 4, and 5 are what we call Pythagorean triples. It's something you need to memorize. 3, 4, 5. So if you ever come across a triangle with a 3 of 4, automatically jump to know the answer to 5.
Really?
If I doubled 3 and made it 6 and 8, that would double also, and that is a Pythagorean triple. If I took 6 squared, added it to 8 squared, it would be 100, and I would take the square root and get 10, and you can just jump fast to the answer. All of you would love to jump fast to the answer. That's why you do. That's why you learn your times tables, is so you can not have to sit there forever and count out all those things.
Does that happen if we double it again?
Double, triple it, quadruple it, anything. If you did the same thing to all 3 of them, it would always be so you could jump to the answer quick. If you knew 3, 4, 5, you'd know a whole bunch. You wouldn't have to use your formula. A squared plus B squared equals C squared. Yes.
My daddy.
So we're going to do number 7. We're skipping 6. It's close to 5. We're jumping to 7. I'm telling you the angle BAD. It's not bad, but it's BAD is 100. And ADC, that's over here. All right, we want to find ABC. ABC, this one right up here. I'm going to make it a different color. We're looking for that one. How in the world are we going to do this? What do we know about kites?
Their shapes.
They're shapes. I get it. What properties?
Opposite angles are
You can.
congruent.
Okay,
Like 70.
So which are all opposite
no,
angles
just one
congruent?
pair.
Just one pair. Which pair is
100.
the 100? So this one over here is also 100. I agree.
Oh, so then we do the 360 thing.
Why is it 360 though?
Because it's quadrilateral.
Because it's a quadrilateral. They add up to 360.
So 100 plus 70.
So we can do 70, should be 100 and 170 add up to how much?
100, 100 and
Uh-huh. How much do all three of these?
both one. Okay, two.
Yes, I heard 270. So I'm going to put this in the box. So 270 plus what we're looking for equals 360. Or if you wanted to write it the other way, 360 minus 270, excuse me, equals what?
90.
Is that true?
360 minus 270.
This is
But
90.
I got my calculator at least.
Notice that my figure does not look like 90. That was not I'm not intending for it to look that way because I could change around all those. I'm intending for you to think about what's congruent and so forth. Okay? Remember that everything that applies to quadrilaterals applies on down. Now I've added to our box. Before we didn't have trapezoids and kites in here. We went over to squares, quadrilaterals, parallel, and so forth. So now we have trapezoids and kites on ours. So now I'm going to ask you, both pair of opposite sides are parallel. Both pairs. Which ones does that fit?
All the parallelograms.
All the parallelograms. Which ones are all the parallelograms?
Parallelogram through square.
Parallelogram through square.
Which number?
Number 9. Number 10, 2 pairs of sides are congruent.
Congruent.
Just so
No.
2 pairs.
No.
That would be an isosceles trapezoid. Oh wait, wouldn't that be kite?
It's kite? Kites have that, don't they? Okay, what else has it? 2 pair are congruent.
Rectangle?
Just rectangle? 2 pairs? A rectangle is 2 pairs congruent, doesn't it?
Yeah.
Okay. Anything else?
Square.
Just squares? Okay, squares because it has
It's
all
a
of them, but 2 pairs at least, right?
So same with rhombus then, since it has all of them. But this is only 2 pairs of sides.
Oh, does yours say only?
Yeah.
Oh, I needed to, yeah, that's supposed to say only right there,
Well,
huh?
then it shouldn't be square either, right?
So then it shouldn't say square, should it? Okay,
Right,
so we
but
gotta
it would
take,
be rectangle.
it would be rectangle?
Because the 2 pairs and then the 2 pairs. So
Okay,
they're-
all right. What about, anything else?
No.
I beg to differ.
Wait.
Quadrilateral.
Quadrilateral.
Not necessarily quadrilateral, because I could draw a quadrilateral where all of them are like different sides. That's almost-
Gosh.
That's almost a trapezoid.
I know. I have to draw it really. There we go.
Oh my goodness.
The one that's
I have one more on there that has
Parallelogram.
parallelograms.
Oh, because they're
But
not.
not all parallelograms.
parallelograms.
It has always, because if a parallelogram was a rhombus, then it wouldn't be,
or a square.
or a square. So not all of them,
so
but
it's just rectangle and kite.
only rectangles and kites.
But it wouldn't even be only rectangles because some squares are rectangles.
Oh, so
So it
it'd only
would
be
just be
kites. Number 11. 11 says at least 1 pair of angles are congruent. At least 1 pair of angles are congruent. That means more of them could be, right? One or more.
Rectangle,
Rectangles have
square, and
1
kite.
pair, more than 1 pair, right?
Yeah, rectangle, square, and kite.
Rectangle.
Wrong one. Other.
Oh, you're right. Down here. Thank you. At least 1 pair of angles.
So rectangle, square, and kite.
Not trapezoids?
Oh,
Yeah, because they're.
But do all trapezoids have angles congruent?
No,
Yeah.
just the isosceles.
Just the isosceles ones. Okay.
So just the
So, and kites have, but they're not necessarily opposite, but they are. All right. Really important that we think about these. That's why we're doing them together. Diagonals are perpendicular. Where do we say diagonals are perpendicular?
Oh yeah, it says perpendicular. I must have jumped to 13 because I read
Wasn't it a rhombus?
A rhombus, I agree. A rhombus has ones. Yep, I agree. What else had diagonals that are perpendicular?
No, kite.
Kites.
Yeah.
Diagonals that are congruent.
Rectangle and square.
Rectangle and square. What about trapezoids? I thought trapezoids had it.
Just isosceles.
Just isosceles, so be very careful. Diagonals that bisect each other.
It's all the parallelograms.
Rhombuses do, yes. Is there anything else the diagonals bisect each other? I mean, yeah. Rhombuses do. I agree. Squares do.
Rectangle.
Rectangles do.
Parallelogram.
Parallelograms do. Last one on that top part. All angles are congruent.
Rectangle and square.
Rectangles have all of, yes, rectangle and, I heard somebody say square. What about rhombuses?
That's two different pairs, right?
Yeah. Their sides are congruent.
Their sides are congruent, not their angles. Okay, all right. So let's move down to place an X in the box for all the possible names of the given shape. Number 22, this time I didn't put words in there like I did in the last one. I put shapes.
You did on 25 though.
I did? Okay. What shape is that one?
Trapezoid.
It's a trapezoid. So you obviously can put one for the trapezoid.
Wait, so where is? Oh, it just falls
But
down.
if it's a trapezoid, is it anything else?
Quadrilateral.
It's a quadrilateral. What shape is the last one? Number 23.
Rhombus.
It's a rhombus?
Yeah.
This is a rhombus. And it's also a parallelogram and a quadrilateral. We have covered so much today. We covered items about kites, trapezoids, and isosceles trapezoids. We have covered so much. It's time to say goodbye.